Oh, dah 34 already. More than 100 registered, right, Mimi? More than 100 registered. Wah, kalau dapat 100 lah, wah. This is beef. I don't think so. So, free and free. That's the thing with free things, lah. People don't appreciate it.
Oh, okay. Can you hear me? I'm going to start recording before I forget again.
So give a few more minutes. We'll start exactly at 8:30. Just a few more minutes. We'll start as we promised to.
All right, 2 more minutes. I'll just start recording anyway. Start chatting.
Okay, we can start now. Okay, guys, good evening. Welcome to our 1 hour talk on electrical safety. Right, as I said earlier, please scan your QR code for attendance. For those who have come in, I think it's also posted in the. Can we also post it in the chat box so that those who come later can also this. All right, so let us move on. All right, we'll talk about understanding electrical hazards, some safety model, basically recognizing, evaluating, and controlling, creating a safe environment, a bit on personal protective equipment, PPE, emergency response, and also before we conclude. All right, so electricity is important in our modern life. Can anybody share with me in the chat box who discovered electricity? Can you guys, maybe we do some interaction here. Who discovered electricity? Can I have see some answers in the chat box? Tesla, I got one answer here, Tesla. Benjamin Franklin, Coulomb, another answer is Coulomb. Anyone, guys? What about the guy who wrongly thought to be this guy is wrongly thought to invent light bulb. Edison, yeah. Edison actually didn't invent the light bulb. He perfected it. He commercialized it. Benjamin Franklin, Tales of Militus. All right, thank you for your answers. Electricity is a force of nature, right? It's created not by human power, right? It's not by human power. It is a force of nature. So the name we mentioned just now, Benjamin Franklin, Tesla. Tesla is Nikola Tesla. These guys, they did a lot of research, especially Tesla. Tesla, he actually perfected the AC current, perfected it, discovered by somebody else, but he perfected it. Benjamin Franklin did some experiment to prove that the lightning, the famous kite experiment, that lightning is actually electricity, and other names like Michael Faraday. Thomas Alva Edison actually he perfected the light bulb and also a few other inventions. And what is that? The Michael Faraday, George amp, where we got the unit ampere, Jock amp, Galvani, right? These are people who did a lot of research in the 18th and 19th century century. So electricity is not a new technology. It is actually quite old as compared to IT and all that. It's quite an old technology. But it is the one technology that actually powered up the industrial revolution, right? Industrial revolution, which again is falsely thought to begin in the Europe. No, it did not begin in Europe. It actually began somewhere near East, right? So, in the 18th century onwards, when electricity was discovered, it actually propelled the industrial revolution. And today, electricity is in our modern life. It's ubiquitous. It is everywhere, right? It power our tools and machinery. Even the fact that we are in contact now, right? I'm somewhere else. You're all in your various homes. No, we are in contact. That's because of electricity, right? It gives us light. It gives us radio communication, right? But you must understand, electricity demands respect. It demands respect because it is one of the original four forces, right? There are actually four forces that the entire universe is created upon. Maybe you guys will know. Uh, what is that? Gravity, strong nuclear power, weak nuclear power, and electromagnetic, right? Electromagnetic. So whatever we can see and whatever we can hear in our modern world today is in the electromagnetic spectrum. And what the human can see, hear, and feel is actually very narrow bandwidth, very narrow bandwidth. So I hope that underscores my point here that electricity is needs respect and it can be very dangerous, right? For those among us here who are electrical engineers or who did some electrical engineering, the whole of electrical engineering and the whole of electrical engineering, if you it actually boils down to bringing electrical current safely to our homes so that we can use it, it can benefits to us, right? Basically, generation, transmission, and distribution, right? Transmission and distribution is bringing electricity safely so that it can be beneficial to us, right? So today we touch upon one part of electricity, that is the safety part of it, right? Because neglecting it, it can give severe injuries and can cause fatal accidents, right? This is something that we want to
Yeah.
avoid. All right. Let us move on to the next slide. Give me a minute here. Okay. Right. Yeah. This is just to underscore, right? Workers are more exposed to hazards because job sites can be cluttered with tools and materials, fast-paced and open weather. Risk is actually higher at work. But if you look at the statistic, of electrical accident, some of the major accidents happen at home. Some of the major accidents, the accidents that happen at home and the accidents that happen in the workplace is almost the same. It's almost the same. In fact, in the factory, if you talk about factory alone, it's actually smaller. The statistic shows that lesser number of accidents happens in factories as compared to our own home, right? So do not underestimate the safety of the electrical safety in our where we live, right? So, and you must also be, we must be able to identify electrical hazards because, when we actually work on electrical circuits, and I hope you guys already know that, our single phase voltage is 230 and our three phase in Malaysia currently is rated as 400. It used to be 415, but now it's 400. Yeah. Serious injury is even, okay, that might occur. All right, here are some of the things that can affect your body. 1 milliampere means ada 2 titik perpuluhan lah ke depan tu. No sensation, probably not noticed, right? So from 1 milliamp to 3 milliamp, there's a mild sensation, but not painful, right? Like a mild sensation. This is still milliamp, still milliamp. 3 milliamp, still 0.03 m, and 0.1 m. So 10 milliamp, you can already feel a painful shock, right? You can already feel a painful shock. This 3 milliamp to 10 milliamp, right? And then from 10 milliamp to 30 milliamp, right? 30 milliamp, if you look at your RCCB at your home, it's set at 30 milliamp, right? So at this milliamp, 10 milliamp to 30 milliamp, human will lose muscular control and muscle clamping. So your muscle can actually cramp, right? It clamp, right? This is 30 milliamp, 0.3, so still very small number. And between 30 to 75 milliamp is actually, you can have respiratory paralysis, right? Your breathing, your breathing might go numb. Your breathing, you might stop breathing. 75 milliamp, the handrail, the handrail that we use, is 10 times more current than 75 milliamp. So 30 to 75 milliamp, you're still in the milliamp range. You can stop breathing, and between 75 to 4 amps. Now only we are coming to 4 amps, right? Now only we are crossing over to the without any number, any zeros in front. You can have ventricular fibrillation. This is where you start, the heart and everything start to go haywire, and over milliamps, tissue will start burning, and the heart will stop beating, lah, right? The heart will stop beating. So just 4 amps, just 4 amps. Four, in our today's world, four is normally four is a very small number, lah. But in electricity, 1 amp is big, 1 volt is small. 1 watt is small. There's almost no, even toys is more than 1 watt, right? But 1 amp is very big, right? 1 amp is very big. So usually when you're talking about ampere, we are always talking about milliamps, right? We're always talking about milliamps, all right? Any questions, guys? Three phase usually minimum how many milliamp? Three phase is 400 volts. Amps depends on your load, right? When TNB, in West Malaysia, TNB supply for three phase is 400. So it depends on your load, lah, right? Because you understand the formula, V equals to, the simple formula is V equals to IR, lah, right? Of course, for three phases, you have square root 3 and times cos theta, which is the power factor. But for today's discussion, we just say that V equals to IR. So V is for single phase in Malaysia is 230, right? The area is your load. The area is your load. So you can actually find your I, lah. And also another formula, P equals to VI, right? P equals to VI, right? P is equals to voltage times ampere, lah, right? Yes, the mini gadget more than 100 milliamp. Yes. It can some battery powered milliamp. That's why it's quite dangerous, especially if it is powered directly to the socket, right? 100 milliamp is quite big, yeah. It's quite big. I mean, in terms of amps, lah, right? Because look at here, 75 milliamps, 75 milliamps can cause ventricular fibrillation. So 100 milliamps is definitely bigger and can cause more damage if you are not paying attention to it. If you're not taking safety into giving safety serious attention, right? So nature of electricity, it involves its current flow. We're talking about electrical safety. We're talking about a current flow, right? Voltage, as we know, single phase in Malaysia is fixed 230. Three phase is 400, right? Three phase is 400, and this is for low voltage, lah. Of course, for high voltage, we have 11 kV, 36 kV. That is transmission and distribution. That is a different topic. There's a different conversation, but when you're talking about electricity, it's always about current flow, right? It's about current flow and component of managing flow. Conductors, as you know, right? Conductors such as copper, aluminium, iron, and many other coppers, they make the passage of current easy, but that doesn't mean resistor it does not conduct current. It just makes it difficult, right? But if the voltage is high enough, there is always a flash over, right? It's always a flash over, right? And of course, we need safety mechanism, lah. Proper insulation, right? Proper insulation. So perhaps this is the first lesson, right? If the conductor's insulation, if your wire is hurt or your wire that is is scraped off or what, you need to change the wire, right? So because insulation is important, and then of course the other one, another important factor in our safety is electrical safety is grounding, which is earthing, right? Earth, so that the current can safely flow not to the body but to the earth. All right. So types of electrical hazard. Arc flash. Arc flash, sudden release of electrical energy through the air when fault occurs. Extreme heat. Arc flash can generate almost 20,000 Celsius, right? Arc flash and 20,000 Celsius. 20,000 Celsius is hotter than the surface of sun, right? And it can give intense light, wave, pressure wave. So this usually happens at HT, right? For high tension installations. arc flash when there's and also it can cause severe burns. So usually these are the worst kind of hazard, right? And those who are exposed, the normal person, the layman should not be exposed to this, right? He shouldn't be anywhere in the vicinity of where an arc flash happens, right? This particular hazard is for people who deal with switch gears, right? With high tension switch gears, with high voltage installations, right? The normal person, uh, even a normal technician or even an engineer who's not trained in this shouldn't be exposed to this, right? So you shouldn't, if you're in a factory environment, you shouldn't be walking into a substation. It is wrong. It is wrong for those who are not authorized to go into substations and HT rooms, right? Only authorized personnel are allowed to it, right? Because the layman shouldn't be anywhere near here, right? Because these are the worst kind of hazard. Of course, electrical shock. Electrical shock is amount of electrical current flowing through the body. It can be as little as we saw, a few milliamps, or as high as a few thousand amps, right? And also depends on the duration of exposure. Yeah, depends on the duration of exposure. You have arc blast. These are explosive effects from the arc flash. Rapid expansion of air and vaporized materials. So when there is an arc flash, there is also a blast. So when blast happens, those things inside the switchgear, it can fly, right? Scraps of metal, right? It can, and those things, and it can, and imagine 20,000 Celsius, a lot of things can be vaporized, right? This vaporized copper and iron can actually fill up the air. So it's also toxic and poisonous, right? Apart from the heat, the amount of heat and the pressure, the sound, the light, you also have vaporized gases, because at 20,000, more than 20,000 Celsius, a lot copper will melt, iron will melt, right? Aluminum will melt, and all this melt become gas, and and the person is exposed to these toxic gases, right? They're exposed to these toxic gases. So it's another serious electrical hazard. And you have thermal burns. This is heat generated from current flowing through the body. Extreme heat and from arc flash. In our slides today, I'm not going to show those horrific pictures, right? Of people getting into accident. I have a lot of collection with me, but I don't intend to show it here because you might not have a proper sleep after this, right? Extreme heat from arc flash, and of course electrical fires, right? Electrical fires caused by electrical fault, short circuits, or overheating. Overheating usually happens when you are trying to force a big amount of a current in a small wire, or wire that is not appropriate to it. And other secondary injuries from fall, such thing, right? So these are the typical hazards uh, of electrical on from the electrical side, right? So the first thing you should do is to evaluate hazards, assess the risk. You guys know, right, between the difference between hazard and risk. Hazard and risk. Hazard, the presence of hazard increases the value of risk, right? The hazard must be present for the risk to be there, right? So you have to evaluate the hazards. The hazards, identify potential hazards, right? What are the potential hazards? The potential hazards are, as I said earlier, those cables that are not properly insulated, right? Uh, and then where the areas, wet areas and exposed sockets, wet areas, right? Not inappropriately maintain power tools such as hand drills and all that, which are not properly maintained, right? And then abusing socket outlets, right? Abusing socket outlets, uh, and also extension of inappropriate extension of socket outlets. Supposed to be uh, socket outlet extensions are supposed to be temporary. It's not supposed to be permanent, right? No, I have seen installations from one wall mounted socket. You have one extension, three, and then from the three another three, right? From the grandfather, father, grandchildren, great-grandchildren. At the end of the day, you get uh, 15, 10 to 15 socket outlets from that one socket outlet, and all kind of devices are fixed to it, right? It increases the amount of load, which directly increases the amount of current, right? So this actually is hazard, right? It's a hazard, all right? And you also have to determine the severity of the hazard, right? The severity of hazard from the worst case scenario is loss of life, right? The least is the mild sensation we talked about just now, right? And also assess the urgency of the risk and likelihood of exposure. Yeah, evaluate how likely exposure is to occur, right? As I said just now, if you have an 11 kV substation in your workplace or in your factory, right? If you're not an authorized person, you shouldn't go in there, right? Because usually, always you can see the signboard is there, right? Unauthorized persons or unauthorized personnel are not allowed. So don't go in, right? For your own safety, and also it's also legally wrong, right? Uh, if you're not supposed to be there and you are there, and if anything bad happens, you will not be able to claim your stock. So you might want to know that. Okay. Right. So control the hazards, implement measures to eliminate or reduce risk, create a safe work environment. We'll see in our other slides, and anticipate unexpected events. A good safety program will always be able to do this and anticipate unexpected events. Right, we have a question here from Fizri. How about ESH fire inspector? Is them allowed to do patrol inside? Uh, a fire inspector and a chargeman are two different things. Nobody is allowed to go inside a 11 kV substation unless it's an authorized chargeman, right? A fire inspector is a fire inspector. He is not an, unless he's a chargeman, lah, right? If the fire inspector is a chargeman recognized by Suruhan Jaya Tenaga, he has a valid chargeman cert, then he can go in. Oh no, he's not allowed to go in. It is wrong by law. Right? You're not supposed to be inside 11 kV substation chargeman. Not even the general manager or the owner of the factory itself can be there, right? Together with the chargeman in duty. Chargeman in duty is the, you see, if you already have a chargeman, what can the fire inspector do? Right? The chargeman is the authorized person there. So I would advise just that the chargeman to be there, right? Unless you have a special permission from Suruhan Jaya Tenaga that says that the ESH fire inspector also can be there, right? If you do not have this kind of arrangement, then if anything were to happen, the chargeman can claim SOXO and insurance. The ESH fire inspector might not be able to do that, right? So we have to be careful of all this, lah. Of course, when nothing happens, nothing happens. Everybody is, happy and everything. But when something happens, then where the finger pointing comes in, and all kind of chaos will happen. So to be on the safe side, get your ESH fire inspector covered, right? The law does not recognize fire inspector inside 11 kV or anything, or inside even a 415 substation for that matter. What is VEE? Anyway, doesn't matter. You need to be a chargeman, authorized chargeman to go in. If you want somebody else also to go in, go and talk to your local Suruhan Jaya Tenaga and get what they say, terhad, lesen terhad lah, lesen terhad, which allows this kind of personnel to go in. All right. I hope I'm clear. All right. Visiting electrical engineer, of course. Visiting electrical engineer are basically competent engineers. They have recognized certs by Suruhanjaya Tenaga. They can go in, yes. You have a supervising engineer. You have what is that? Service engineer. Yes, they can go in because they have competence. They have competence. What is that? A certification from Suruhanjaya Tenaga, right? So these are authorized personnel, lah. Okay, let us move on. Recognized hazards. recognize hazards. So you must be aware of electrical hazards, potential of electrical hazards in the work environment. All right. So to do this, you need to do an audit, lah, right? Need to do an audit, check your tools, check those socket outlets that you can see some of the socket outlets are a bit shaky and loose and all that. Get your technicians, your chargeman, your technicians to get this repaired, right? Understand situation that could cause harm, and also actively identify and do regular electrical check for electrical hazards. Electrical hazards need to be checked by those who have knowledge about electrical hazards, right? Uh, yes, everybody needs, yes, domestic users, yes. If you go to Suruhanjaya Tenaga website, you can actually see a lot of free, what I say, free resources, lah, which there's a lot of advice on domestic one, right? So, actually, it's quite easy, lah, right? Don't go and switch on anything with your wet hands, right? Fire and electrical they're not friends, they don't go well together, right? Make sure your cables are safe, are not scrapped off, or there's puncture any somewhere, right? Do not poke things in the socket, right? Uh, Make sure do not use uh, electrical equipments that, how to put this in a nice way, that you all buy from all these online kind of things, which is no serum, nothing there. There's a lot of cases. There's one case where this person, quite recent, there's one case, this person, after delivery, this young lady, after delivery, she bought this, what they call it, this electrical tunku, right? And it malfunctioned, and luckily nothing happened to the life, but burn, right? She got burned, and there are also a few cases of this. So when you buy things uh, from this online, make sure it is properly. Uh, I mean, to put this very straightforward, it has valid serum hologram, not the fake one, right? And even if you're buying for your factories or for your, for others, make sure that you buy those original things, which might cost a bit more, but it's a bit more safer, right? In Malaysia, as long as you have a valid serum, it is okay. Don't worry about CE and US law. We are not in US. So you are in Malaysia, so as long as it's serum, we are good. Those CE and US one, I don't know, like every item you buy, don't know. Every item sometimes you buy, you put CE and what all this, but I would like to see a valid serum one, right? I've also got a serum hologram there, valid one, not the duplicate one. It should be okay, lah. But of course, it's very difficult to see which is what is that duplicate and what's the real one, right? Any questions before we move on? Okay, let us look at. All right, importance of de-energizing, and when you are, I mean, if you are domestic, you call your proper wireman to do the electrical work. Don't go and do yourself, right? But if you're in a factory, make sure that and if you're responsible for it, make sure that your technicians, your guys have de-energized, right? When they're doing electrical work, meaning that they switch off the what is that, MCB, MCCB, and all that before starting work. You need to do testing, right? Troubleshooting, and also that voltage threshold. You must understand that IEC, the International Electro-Technical Commission, which Malaysia is a member of, I stated that 50 volt is dangerous. Anything more than 50 volt is dangerous. We're talking about voltage, not current. Current, as you can see, milliamps can cause damage. But anything more than 50 volts is considered dangerous, right? So these are the first things you must do before beginning any work. Like de-energize. De-energize means not switching off the socket. You switch off at the distribution box, at the DB box. All right. And then you need to have what is that? Shutdown preparation for shutdown, right? Your lockout, tagout procedures. Identify all energy sources. Review the procedures, right? shutting down equipment, follow specific directions for machinery. These are lockout, tag out, and this is a lifesaver, right? It's a simple procedures that can actually be very useful for a lot of safety concern, especially electrical safety, right? The third here is isolating equipment. Means you isolate the equipment. Isolating equipment meaning that you are making sure that there is no accidental uh, electrical current flow to the equipment, right? Then you apply the lock and tag. And when you do this, when you're applying the lock and tag, the key, if you are the person who doing lotto, lockout, tag out, you are the only person should hold the key, right? There should not be any duplicate of the key. You should not leave the key where you have locked the switchboard, the distribution board. You should not leave the key on your office table. You should not leave the key, give it to anyone. If you are the person in charge, or the person in charge should hold the key until the lockout, tag out procedure is completed, right? And it should be only one set of key, only one. All right. Then release stored energy. Release stored energy means make sure you have done the grounding and all that. Then you must verify there is no absence of voltage. Certain electrical equipment, motors, and all that, they can keep what they call inducted voltage, right? There is this, what we call inducted voltage, which can give inductive current. So you need to make sure that all these are released. So there is no absence of, direct voltage or those voltage that is kept inside the coil of the motor, right? And of course, you need to apply temporary protective grounds, earth in this case, right? So this is our lockout, tag out, easy to follow, cost effective. Yeah? Okay, you must understand that tags do not prevent analyzation. Tags are just tags. Just a tag there telling that, man at work. It actually doesn't prevent analyzation, right? You have to know, you must understand this. Of course, complex lockout, tag out procedures where multiple energy sources are there. All this you need to plan properly, right? You need to plan properly and communicate it to everyone in your factory, and especially those who are doing the work. Grounding or earthing, grounding is actually a US term, right? Earthing, in Malaysia, we usually use earthing. I need to correct this slide. Okay, importance of proper grounding or earthing is to provide a safe path for fault current, right? Minimizes the risk of electrical shock. So when you have a proper earth or proper ground, if there's any leak, any short circuit, there is a safe passage to the ground or to the earth, and not to the human body, right? So this minimizes the risk of electrical shock. You have temporary protective grounds used to de-energize lines or equipment, protects workers from re-energization and induced voltage. These are the voltage that kept in the coil, such as your induction motor and all this. Then there are circuit breakers such as MCBs, right? MCBs in Malaysia, there are 10 amps to 100 amps, but in Malaysia, usually our MCBs are limited to 30 to 40 amps, right? Or maybe the highest is also 60 amps. Then you have MCCBs, right? MCB is miniature circuit breaker. MCCB is a metal clad circuit breaker, right? And all this with your RCCB, your residual current circuit breaker, all this offers additional shock protection, right? All this offers additional shock protection. So all this must be regularly checked and replaced if it's not working. Yeah. And then you have insulating materials, as I said earlier, to prevent accidental contact with energized parts. Use appropriate materials. Guys, you must understand that when it comes to safety, whether electrical safety or whatever safety, scaffolding safety or steam engine safety, there is no compromise. We cannot be looking at cheap, ineffective solutions to this, right? Because there is no compromise on safety. So make sure that appropriate materials are used, all right? Then one of the easiest ways is actually to physical barriers, fences, covers, enclosures, and also you can also, like your switch box, your DBs and all that, you can be inside a riser or a certain room and lock the room, right? And keep the keys protected also. And then, of course, you have proper clearance, right, around electrical equipment, proper lighting. You need proper lighting also, right, around power lines, right? Do not go and work where there's no light, especially electrical things. Especially people like to reach things that they cannot see, right? They maybe where they want to repair something high, or they want to check something, they will try to reach, but they cannot see where their hands are going, right? So these are quite dangerous, right? So make sure when you're doing electrical works, you have adequate lighting. You have adequate lighting. Okay, temporary power excavation safety. This is very common in our country. Unfortunately, you don't get to hear this. We get to hear the big case lah, right? The gas pipe that happened in Putra Heights, that we hear of, right? But there's hundreds of cases that this excavation hits cables, right? And there's a lot of it goes unreported, and a lot of things, even is reported, the general public does not know, because uh, uh, we are not there yet, right? We are not there yet. We're supposed to do mapping and to locate the cable underground and that, but we are not there yet. There are some states are quite serious with this. Some states are not. So there's excavation happening somewhere, make sure that uh, what is that? It is not doesn't go to hit anything, right? So temporary electrical power distribution, also proper design, exposure to weather and potential sources of flammable environment. All this, apart from the excavation safety, will also need to be properly assessed. Okay. All right. Communication is important, yeah. Job safety plan. Conduct a thorough safety plan before starting any job. Identify potential electrical hazard. This needs to be done by qualified personnel, right? Qualified personnel, so that they know what they are evaluating, right? There must be a job briefing, discuss, review, and if you're going to send someone to work alone, thoroughly assess the job, right? Usually this electrical work usually send two person, but if you can't, most of the time, if you can't, try it. If you're sending one, make sure it's simple jobs, and all that, and the people that you're sending are properly trained and know how to assess the risk and the hazards. Of course, this is important, proper use of tools, right? Ensure tools are used as intended, maintain tools in good condition, right? Also use tools related to the voltage being worked on. So don't go and use tools, single phase tools for three phase work, or single phase multimeter for three phases of work, right? So you need to use the proper tools, and also this is prevent unintentional contact with energized parts, right? So always be aware, uh, with your hands, right? With your hands, where you're putting your hands, right? Because there's a lot of cases, people having spanners and screwdrivers, they accidentally touch energized parts, and depending on the duration and the amount of current, the damage done can be quite severe to the human body, right? Visual inspection of tools, yes, we spoke about this earlier. So need to properly make sure the tools are inspected. Yeah, we revisit what I said earlier. Avoid wet conditions. Electricity and water are not friends, right? Avoid handling energized plugs or equipment with wet hands. Do not use electrical equipment in wet, flammable environments. It happens. This accidents goes unnoticed, unreported. Uh, a lot of people working in wet areas are not properly taking the safety precautions, and also be aware of battery operated tools, right? Today battery is uh, especially rechargeable batteries are very common, right? It's becoming more common as we move into portable durable equipments, portable durable world we are in today. We have a lot of battery operated tools, including your electrical car, so uh, we generally in Malaysia we use the word battery and rechargeable battery, right? But technically, just for your info, battery means you can recharge. Those that cannot be recharged is called dry cell, right? Those that cannot be recharged is called dry cell. Dry cell means that you have AA battery and the AAA battery which you cannot recharge is called dry cell, right? Battery, when we say battery, is basically means it's rechargeable. right? It's rechargeable. And this is becoming, with the advent and with the popularity of electrical cars here, so battery and battery safety is becoming a very important topic. Yeah? And also with the handphone, there's a lot of cases where, handphone handphone battery exploded and all that. Right? So be careful with battery operated tools. As I said just now, uh, IEC as said that 50 volt is dangerous. Just 50 volts is dangerous, right? Right, possible equipments. Yeah, manufacture. Okay, it's important that actually nobody does this in our country, which is following the manufacturer's rules. But it's best we keep to the manufacturer's instructions, connect the plugs and sockets properly, and grounding type of sockets, lah, right? All right. PPE, your personal protective equipment, is the last resort. It's not the first resort. Yeah, your PPE is the last resort. It protects people, employees from serious injury, use when hazard cannot be completely. So the first step is to try to completely eliminate the hazard. If you cannot eliminate the hazard, control the hazard. If you cannot control the hazard, then it's when PPE comes in, right? So a combination of controlling the hazard and PPE creates a much safer environment, right? Creates a much safer environment. Right, have an arc rated clothing. So this one is usually for chargeman, 11 kV chargeman, 33 kV chargeman. You should have what we call arc rated clothing, right? Include shirt, pants, coverall. I think this costs about 3,000 to 4,000 per suit. So if you have 11 kV or higher substation in your vicinity or in your factory, you need to make sure that your chargeman has this arc rated clothing. Including the goggles, and not the normal goggles. The normal goggles will melt, right, and injure the eyes. These are fire-rated goggles, fire-rated gloves, right, fire-rated shirt, pants, and jackets, right. Also have, and it's rated in calorie per centimeter square, right? Calorie per centimeter square. You can talk to the provider, right? 11 kV, 33 kV, under 32 kV. There are different specs that you need to meet, of course, with different prices, right? I think the 11 kV one, if I'm not mistaken, costs about 2 to 3,000 ringgit per suit, if I'm not mistaken. So if I'm wrong, I'm sorry. But you can check with your manufacturer. It's around that price, right? And make sure you get the proper one, right? The original one, yeah. You really have to make sure it comes with a certificate, right? Don't get scammed, right? Okay, you have to be risk aware. We talk about risk awareness just now, and also chemical hazards from electrolytes, right? Chemical hazards from electrolytes, potential explosives of gas. This is battery, This is the battery safety, right? All batteries, there's electrolyte inside, even so-called dry batteries, right? It has electrolytes inside for the electrons to move. So be careful of leakages of these electrolytes. And safety measures, I think quite common sense. Avoid smoking in open flames, near batteries. Make sure your batteries and heat does not go too well together. Yeah. Whether even if your handphone battery, I think we are aware of this. So don't let the battery get hot. There is a potential. There's a risk of it exploding, right? So if you are handling a lot of batteries in your substations and all that, make sure that the environment is, of a certain temperature, preferably below 27 or 26, right? Around room temperature 25 and all that, right? And be careful when handling electrolytes, and should be people are trained in this. Okay, if you go to Suranjaya Tenaga, you will see that the statistic shows that the number one cause of electrical safety is human error. Uh, by far, almost 90% of electrical safety failures in our country is human error, right? This attitude of assuming, right? Assuming. And if you go to Suranjaya Tenaga and you have a discussion with them, they'll show you a statistic shows that the older the chargeman, the older chargemen, those who are more than 20 years working experience, they are the one who get involved in accidents, not the one that just graduated or just got their certificates. The younger ones are always careful. The older chargemen, because they have worked 10, 15 years without anything happening to them. So this attitude of never mind, this sambil lewa, ataupun semua saya tahu kind of attitude, which is uh, very common, is the one that causes causes accidents, right? So when I was first showed this statistic, I was quite shocked. I assumed that the younger one would get into accident, but no, it's the older one. So when we asked the authorities why this happened, they said that because the more experienced the chargeman is, the more he assumed things. Oh, this will be okay. I've checked that. Oh, semua okay. No need to worry. And that is where accidents happen. So if you can take away anything from today, take away two things. First, have a checklist. Second, make sure the checklist is done. And number three, and the most important one, don't assume. When it comes to electricity, do not assume, right? Because the price can be very, very high, right? Uh, Factors that increases human error, rushing, high workload, distraction, lack of familiarity with task, and in Malaysia, unfortunately, is overconfidence, right? I'm not saying this, this is what authorities told us, right? Overconfidence, right? Uh, very, very less than 10% because of equipment failure or equipment malfunction, right? 90% is human failure, human malfunction, attitude, right? Which got to do with the human attitude, right? So just make sure we do not fall into this trap. All right, let's move on. Okay, these are some simple things. Do not touch, when someone is being electrocuted, don't go and touch, don't be a hero, right? Don't go and touch the victim directly, because you become a conductor yourself again, right? The person in front is getting electrocuted is a conductor, and when you try to drag that person, you also become a conductor, right? You should switch off at the main, right? Switch off at the main. So don't go anywhere near a person who's getting electrocuted, right? No matter how much, uh, even if the person is your BFF, right? Go and switch off the mains first, right? And then only trained personnel should release the victim, right? And only trained personnel should give CPR. So, right, because all these are regulated items, okay? So, assess the victim condition. I have training for employees, first aid, and also the importance of prompt action. First of all, we shouldn't be this. First of all, we shouldn't be in this position, right? But when we find ourselves in this position, this way expecting the unexpected, we must have a team of people who can respond quickly, right? Who can respond quickly, okay? And also important that the location of the ABC or the what that fire extinguisher is known, and people are trained, right, to use it. So a lot of people are not trained to use this one. So it's good to have this kind of training, so that people who work in nearby electrical installation, or people nearby there, know how to use these fire extinguishers properly, right? No point in having the fire extinguisher there, and no one knows how to use it. Okay, right. Just coming back to this again. Never use water on electrical fires. Preferably use CO2, right? But you can also use ABC. The ABC fire extinguisher that we have, that also can be used, but it's preferably to use if you have CO2, the 5 kilogram CO2 fire extinguisher, right? Okay, so understanding electrical safety is not about rules, but understanding potential energy, identifying risks, and implementing control, recognize hazard, right? Evaluate the risk, try to use lockout, tagout wherever is possible, use appropriate PPEs, plan and communicate, very important, vigilance and commitment, right? These are human related items, lah. And that's it. We have come to the end of our presentation. We have about 10 more minutes to go. We are open for questions. Please scan to review. Please scan and review this. And we have 10 minutes. We can have questions, Q&A time. Let's check the chat. Oh, there's 12 messages. Okay, okay, Sharimin. Thank God you're okay. Sharimin was Rajatan Electric for a while. Ada rasa sakit betul lah. Rasa sakit lah. Electricity doesn't, electric, my instructor like to say these words lah. My instructor, uh, because I used to work in 132 kV installation. So the supervising engineer that I work with, he likes to say this. I want to share with you this lah. So electricity doesn't recognize, doesn't care whether you believe in it, whether you can see it, whether you believe in God or you don't believe in God. You touch it, you'll feel it. Right? So electricity doesn't respect us. You need to respect the electricity lah. So this is what my supervising engineer, when I first started work in 132 kV, this one, he always told us this, uh, so that always put it, and he always make sure that we check, recheck, and check. So just sharing with you guys lah, right? So because it is one of the four forces used to create the world, right? The creator used these four forces to create the world. One of it is electromagnetic, right? It's one of the four original force. So it is very powerful. All right, Sirhan, 33 kV Chinaman. So I think you know a lot of things about this, what we shared today. Okay, all right. So thank you.
Majid,
There's a lot of feedback.
Majid,
A lot of
Majid,
feedback.
can you hear me?
So, okay, the question here, sir, for the big DB box, main incoming perlu letak cache ke? Is there any suruhanjaya tenaga requirement? Uh, if you see, sometimes the DB box, Hafiz, sometimes the DB box can be big, but what is the incoming current? You can know the incoming current. You can check with your charge man, right? But it doesn't matter how big the DB is. DB preferably should be locked, right? Preferably should be locked. It should be locked. If you can put a cache, you can put a cache. But why? And especially in a lab, lab if people can reach, kalau tak pakai tangga pun can reach, okay, then it is lah, lab sometimes people try to be too clever, they trip, dia pergi check, dia dah trip, tapi dia tak panggil technician, dia tak sabar technician datang ke apa, dia pergi on sendiri, which is not a good thing to do. So uh, I used to work in a lab also, right? So what I did at that time is what we did is we log all the DB down. We log all the DB and we keep the DB in the key in our maintenance office, right? So kalau boleh you pasang lah. It's actually good. This is called simple procedures to prevent safety. Actually, guys, you must understand. Electrical short is the amount of current that goes in the body. It's not the voltage, It's the amount of current that flows into the body and the duration. And amount of current and the duration you expose. These are the two important things. Berapa lama dan berapa banyak arus elektrik yang mengalir masuk dalam tubuh kita, that determines the severity of the electrical shock to us, right? 500 kV, this you are naturally you're lucky because you tak lekat, it push you off. There are two things, satu lekat, you pegang you lekat because your muscle cramp. Your muscle cramp, you tak lepas, you nak lepas Your body, your mind is sending the signal to the hand to lepas, but dia tak sampai. It cramp, right? Your body, you cannot control already, right? So this is the most dangerous one. You lekat, your one you want push off. So in a way lah, not that bad. Especially kalau dia tolak, is different from kalau you lekat. The lekat one is the more dangerous one, right? Alright guys, any questions? So I hope you have scanned to review. Okay, for the genset under the, oh yes, you must register. Genset must register. 100 kV is considered quite big already. It's KVA lah, 100 KVA is considered quite big. Need to register with Suruhanjaya Tenaga and need to get license and renew every year. Wow, the first incident when I graduated, aduh. Okay lah, still have time. This okay lah. This incident
Share lah.
happened to me when I first graduated. It's a long story lah, but to make the story short, there was this one chargeman. This one chargeman. Uh, at that time, I just graduated. I just the first within the first 3 months, I graduated. As I said earlier, we work in 132 kV installation. The factory that I worked, incoming was 132. This was in Penang at that time, so it's 132. So after a shutdown of 10 days for maintenance work, a 10 days shutdown of maintenance works, we supposed to start our factory step by step lah, right? That night. So, and this is my first job after 3 months. So my boss at that time probably thought, I'm fit enough to do the job. So he asked me to take charge of this area. And that area is where we have 11 kV substation there. 11 kV substation there with a chargeman, lah, right? The chargeman. So what happened was that this 11 kV is coming from another 33 kV, right? This 11 kV is coming from another 33 kV. So before we do our testing anything, we want to make sure that the 33 kV there is off. So what happened was the checklist, right? That is the first item, right? Make sure 33 kV is off. So when the chargeman came, I asked him for the checklist. He said, "Oh, I forgot the checklist." And then he said, 33 kV is off. So I said, "I want to see the checklist." He said, "No, you have to trust me." So I told him, "No, you're not allowed to switch on until I see the checklist." But chargeman, sometimes they probably saw me, this guy just graduated, he doesn't know anything much, which probably was true at that time. So he went, there were two technicians with us, right? The two technicians with us, the chargeman and I. So 4 of us. And I told the technicians, if you want to go in, you're breaking the law. I would rather not you go in. So one guy went in, the other guy with me was outside, right? Was outside. So after a few minutes, we heard a loud bang, right? We heard a loud bang, and these two of them, this technician, he came out, fell, and the chargeman was there inside. Of course, this happens. I'm making the story short. Of course, there's panic and all that. I was very young at that time. So what happened after all that? We brought him to the hospital, and the wife came. The wife came, walked past through him. She couldn't recognize her husband. She walked to one end. She came back and she asked me, "Where is my husband?" The husband was just lying in front of her. She couldn't recognize him. The face was swollen, burned, but ajal tak sampai lagi lah. He lived lah. He lived, but I continued working there. He came back to work. At that time, not like today. Today things are more strict. So he didn't lose his license, right? Even though Suruhanjaya Tenaga, that time not Suruhanjaya Tenaga, that time was Jabatan Bekalan Elektrik dan Gas lah. No Suruhanjaya Tenaga yet at that time. Right? This was in the 90s. So he didn't lose his license, so he came back to work. But until the end, until I left that factory 4 years after that, he couldn't control his saliva. Every time he talks, the saliva will come out. So partially paralyzed in the face. So that lesson taught me to respect electricity, right? So that is the short story. So maybe, because requested by Mimi, that story will be very meaningful, but very impactful if I tell direct. Somehow online, it loses the impact.
Yeah, but still good experience to share lah.
Okay, there's a question here. So how about the requirement to put? Yes, you need to put rubber in front of your switch gear. It is there. It is there in the Akta Bekalan Electric 1994. You need to put a rubber panel. It must in front of your switch boards lah, or your switch gears lah. Not in front of your DB. DB you have everywhere. I mean your switch room, your LV switch room, your HT switch room, wherever is the switch room there, you have a switch gear there. You must put a rubber panel, right? Hope that answers the question. Yes. Thank you, Fizri. In ST Regulation 19 stated, yeah, there it is in the Suruhanjaya Tenaga Regulation 19 stated. Right. Thank you for that. Usually fixed need safety boots. Yes, your safety boots is not the same as your construction safety boot. The electrician safety boot is different. You shouldn't have a steel plate. Your, the electrician safety boot shouldn't have a steel plate. It is different. It is fully insulated. That one with the steel plate, that one is for construction workers, people who work with heavy weights and all that, not for the electrician. Okay, you need to keep that in mind. So when you're buying safety boots, don't simply go and buy safety boots and then you become us because there's a steel plate there. Shafiq, yes, there is a 2 days training in this. You can contact Mimi, Puan Mimi on this. There's a 2 days training. We do this north, south, center of Malaysia lah. Right? We go north, we go center, and we also in the south of Malaysia doing electricity safety courses. It's one of our most popular courses lah. So you can talk to Puan Mimi. Mimi, maybe you want to share your handphone number in this one so that people can get in touch with you. Okay, guys. Yeah, almost at 9:30. Any questions? Right. So that's you can go to info@mapstraining.com or also this the number lah. Oh, yeah, photo session, correct. Lupa pula kan. Ini kita ada recording, nanti lupa foto pula. Guys, if please switch on your cameras lah. We want to get a group photo for our record, for National Training Week record. So we'll be very thankful if you can switch on your camera just for a short while. Kita ambil gambar beramai-ramai. Sirhan, that's a good one. Apapun jangan terlalu overconfident. Dengan electrical pun sama, dengan benda lain pun sama lah. Jangan terlalu overconfident.
Sorry, saya tengah drive juga ni. Nak sembang.
Right, Mimi, are you ready? Right, you're welcome. So Mimi, are we ready with the photo? Aduh, how to take photo? I never done this. Where should I go to take the photo, Mimi? I tak pernah buat semua ni lah. Photo. Anyone, can you help to take the photo? Macam mana ambil photo ni? Show me.
Okay, everyone. Because I'm using tab. Anyone can take photo. Sorry, I'm actually outstation. I've got.
How do we take the photo, Mimi?
You, kalau everyone on the same page, you just print screen pun boleh. Nanti you just share dekat WhatsApp. Kolishi, can you help take photo and send over? Can boleh? Sorry.
Okay, let me stop the screen. Okay, all right.
Sorry, guys. Okay, semua senyum
Tak dengar, Mimi. Sudah ambil foto Done already.
No, kok.
We can't hear you.
Sorry, Kolishi will be taking photo.
Have you done the photo? Are we good?
Kejap.
Oh yeah. Yeah, camera on. Alright, Mimi, dah.
Okay, ambil menu lah. Okay, kejap.
Orang nak tidur dah ni.
Shit. Okay, start. 2 more minutes.
Ya. Berapa lama nak senyum ni?
Okay, one more.
Ya, ada orang dah tutup kamera dah. Right.
One more.
Right, guys. Okay, right. We are ready. Right.
Okay, done.
Okay, alright. Done, huh? Okay, we are done. Thank you very much for your patience. Thank you very much for listening. If any questions, the phone number is there. You can contact Puan Mimi. Have a good day. And see you all some other time. Kalau rezeki kita jumpa lagi. Bye. All right. Good night. Good evening. Have a restful evening. Take care.
Baji, you cannot hear me, is it? You cannot hear me, ah? Hello? Baji, can you hear me? Thank you. Siapa saya punya ni problem? Hello, Majid, can you hear me? Hello? Hello? Siapa enter lagi? Tak boleh dengar langsung
No, you at all today. Langsung tak dengar. Satu perkataan pun tak dengar.
Aduh, I don't know what's wrong. Because ni
You're using laptop ah?
tak, I using tablet sebab laptop I'm doing some work. Then bila I swap balik ke sana, then dekat tablet I say shit, macam mana aku nak ambil gambar?
Oh, okay.
Ada 2 orang baru nak masuk ni, but I cannot talk to them. How? Tapi kau dengar kasi bersuara kan tak? Boleh lah.
What's that?
Patrick can hear my voice.
But we cannot hear you. I think nobody heard you just now.
Itulah. What the hell, man? Maybe tak masuk. Habis kot ni. No, I can see the bar is moving. The bar is moving. The sound.
Hari tadi Shopee ada kejap, tak ada kejap. Today
Terus ada.
100% tak ada, langsung tak dengar.
Shit, man. Dah lah esok I punya session. Apalah.